Prepare for blast-off, because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon, Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now let's check out Titan's celestial credentials. It's not just any moon. It's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It'll feature the Drill for Acquisition of Complex Organics, DRACO, instrument, which will help us scoop out material from Titan, while the Dragonfly Mass Spectrometer, DRAMS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious, dense atmosphere that kept everyone on their toes. Now let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there. So all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor, literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say, the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper Belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are 2 possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years.
Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples, and this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us, or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
Look up. Find that little yellow dot. That's Titan. It's Saturn's largest moon, and the second largest moon in our whole solar system. And it might be the only place in our solar system where there's liquid water, besides Earth. Plus, it has an atmosphere that serves as a shield against solar radiation and cosmic rays, just like Earth. If life was a house, Titan would have a lot of the bricks you'd need to build it. Strap in, you're heading over there. It takes a long time to get to Titan, but you know, the magic of YouTube. Here it is, a bit bigger than our moon and a whole lot heavier. It's even bigger than Mercury. That means its gravity is still pretty weak. You'll feel 7 times lighter here than on Earth. At the local gym back home, you can lift 150 pounds. On Titan, you can lift more than 1,000. Ha! Looking good. The surface is mostly made up of ice. It has small mountains, craters, and a few cryovolcanoes. Basically, the same as a regular volcano, but instead of lava, this beast spits out water, ice, ammonia, and methane. There are lakes and clouds, kind of like a canyon would look like on Earth. But here, there's only a tiny difference. Everything is covered in thick fog, and sometimes it hails frozen methane. On Earth, we use methane as fuel because it burns. But on Titan, there's no oxygen. Can't get a fire going on this hunk of rock. No oxygen means you need to put on an oxygen mask, but you don't have to wear a whole spacesuit like on our moon. Titan has a stronger atmosphere, but you packed a sweatshirt, right? It's gonna get pretty cold soon, like negative 300 degrees cold. The coldest it ever got on Earth was negative 128, and that was right at the South Pole. It's so cold because it's so far from the sun, almost 900 million miles. Anyway, that dense fog and atmosphere stop the sun's rays from warming the surface. Sounds kind of extreme, but so is life. It can survive almost anywhere. Take the bacteria Dano, some long Latin word. It can survive radiation and extremely low temperatures. It even survived a whole year in outer space, on the outside of the International Space Station. Titan would be a piece of cake compared to that, especially if we drilled down a bit. Many scientists believe there's a whole ocean under the surface of Titan. Saturn's gravity gives Titan's core a little heat boost. Plus, there's ammonia in that ocean. It's like Titan's version of antifreeze. As long as the water stays liquid, life's got a pretty strong chance of success. So what's down there? Scientists have actually found real evidence that Titan might already have life on it. Here, check out this microscope. This is C3H2. It was discovered by this weird group of antenna things living in the desert in Chile. It used 66 antennas, all pointed at the same place in the sky. This C3H2 molecule can act as a building block for DNA, the code of life. Some people think that these molecules were around on our planet billions of years ago, just when life began. Scientists also checked it out firsthand with a probe that actually landed on Titan. Turns out those desert antenna things were right. Titan shot to the top of the list of places we could one day live on. Sorry, Mars. NASA has a new project, the Dragonfly mission. They're gonna send a drone out there and explore Titan even more. The mission's still about 6 years away, and the rocket will reach Saturn's moon 9 years after that. So we're gonna have to wait a while before we pack up and move to Titan. After the Dragonfly drone lands on Titan's surface, it's going to whiz around like a sort of double helicopter. It's going to have 8 propellers, 3 feet wide. Since there's weak gravity, that's more than enough to give the drone good cruising speed. It'll be able to fly about 2 miles straight up and take off and land vertically, like a regular helicopter. The main problem with the whole thing is the drone's batteries. Scientists invented a generator that converts thermal radiation energy into electrical energy, whatever that means. One battery charge should be enough for several hours of continuous flight. The Dragonfly is going to be carrying a lot of research equipment, so it's not like those drones people fly in the park on a Sunday. It's going to weigh about as much as 3 ostriches. It's going to have 2 drills, a bunch of sensors, a spectro thing to find out what chemicals are lying around, and it's also going to have its own weather channel with a ton of instruments to measure temperature and clouds and stuff. And like any gadget nowadays, it has a camera on it. Get ready for some beautiful pics of Titan's epic landscape. Nighttime on Titan lasts about 8 Earth days. That's when the drone's going to be relaxing on the surface, recharging and analyzing samples. That's a long time, but it's actually a good thing. Titan's distance from Earth causes a bit of a problem, a delay in communication. When they send the Dragonfly a signal from Mission Control, it has to fly halfway across the solar system. Takes over an hour. In contrast, the signal delay to Mars can be as little as 10 minutes, and the signal delay to the Moon is only about a second. Scientists expect Dragonfly to provide more information about whether we can live on Titan or not. Some experts hope to find a primordial soup there. It's a whole mush of stuff needed to make life. We had that same soup on Earth about 4 billion years ago, and every single living organism that ever existed evolved from this mush of organic elements. If the Dragonfly project's a slam dunk, and Titan does turn out to be habitable, it'll have one more mission: to find a nice place for us to settle down in. But creating a self-sustaining colony on another planet would definitely be the hardest thing humans have ever done. First hurdle: energy production. Probably some sort of nuclear power plant. Then comes shelter for humans and their machines. Those new Titan buildings will have to protect us from the extreme cold and bad weather. Then, drinking water and oxygen. We'd need to invent a way of collecting or engineering both. Then, greenhouses for growing food. We'd also need to mine fuel for transportation. Luckily, Titan's packed full of methane, which is great for fuel. One huge problem: gravity. Because it's so weak on Titan, whoever lives there could lose a lot of muscle mass, making it hard to work and even just live. And there are those pesky cryovolcanoes shooting stuff out at random times. Or maybe we'd need a more drastic, daring idea. How about changing Titan's atmosphere so we can breathe on it and not have to wear about 100 hats and gloves? To do this, we'd need to terraform Titan's surface for a long time. Titan's atmosphere needs to be enriched with oxygen for us to breathe, and it would be great if it was a bit warmer. The next step is to create a biosphere, which means plants. We could turn Titan into a blooming jungle with plants brought over from Earth. But because of pressure and gravity, they'd look completely different from Earth plants. They might all grow super tall, or maybe they'd all shrink down to mini size. We really don't know. First things first, we need to make sure that life is even possible on Titan. Scientists recently thought there might be life on Venus. It's sort of the same size as Earth, and scientists even call it Earth's twin sister. They discovered a gas on Venus, phosphine. Supposedly, it was made by living organisms. Turns out it wasn't true. Well, not really. There is some phosphine floating around, but way less than we first thought. Look, science on other planets is super hard, people. We're always making mistakes like that.
Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede. And it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that, being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the Moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 OF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the sun will become a red giant. It will heat up most space objects in our solar system, and Titan will become warmer, 94 OF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious. but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation: phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus,
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains in Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that. The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, Other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is. But we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the test satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot, 4-inch wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry him there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in. Our universe is starting to glitch, and it looks like we're going through the biggest tension in astronomy since Einstein redefined gravity. But scientists aren't having a cow yet, because this kind of chaos usually means we're about to discover something huge. So let's run through the biggest issues driving the crisis. For decades, cosmology ran on the idea that the universe should look uniform in all directions for anyone anywhere within it. They call this idea the basic cosmological principle, not to be confused with the cosmetological principle, which states all women should wear a color of lipstick right for them. But I digress. Cosmologically speaking, it means you might see clumps up close, but on massive scales, everything should smooth out. Because of that, scientists figure no structure should be bigger than about 1.2 billion light-years. Yeah, that's big. So they were more surprised to find a structure called the Big Ring. This thing is nearly a perfect circle made of galaxies and galaxy clusters, and it's about 1.3 billion light-years wide. Now, a light-year is the distance light travels in a year, and since light is the fastest thing in the universe, that already tells you how enormous this distance is. If your eyes could see it, it would stretch across the sky like 15 full moons lined up side by side, see? And the Big Ring isn't alone. A couple of years earlier, the same astronomer spotted something called the Giant Arc, a curved structure stretching 3.3 billion light-years. Then there's the giant GRB ring, found in 2015, with a mind-melting diameter of 5.6 billion light-years. The Big Ring and the Giant Arc show up in the same part of the sky at about the same distance from Earth. So there's a real chance they're actually parts of an even bigger structure hiding in plain sight. Now, another scientific drama has to do with something called the Hubble constant. That is, how fast the universe expands, the connection between how far away an object is and how fast it's moving away from us. That number helps scientists figure out the age, size, and future of the universe. The Hubble Space Telescope determined that number with an accuracy of almost 1%. The universe is about 13.8 billion years old. So there was Hubble, and later the James Webb Space Telescope that measured distances to faraway galaxies and figured out how fast they're moving away from us. In everyday terms, they showed that for every million light-years you go out into space, galaxies move away about 45 to 47 miles per second. That expansion speed lines up nicely with a universe that's 13.8 billion years old. But there's another totally different way to measure the universe's expansion, and it looks way further back in time. Scientists study the cosmic microwave background, or CMB, which is the leftover heat from the Big Bang. It's the oldest light in the universe, released when the universe cooled enough for light to travel freely. When scientists use the CMB to calculate how fast the universe should be expanding, they get a slower number, about 42 miles per second per million light-years instead of 45 to 47. Now, that might not sound like much, but in cosmology, that gap is enormous. Both methods are extremely precise, and yet they stubbornly refuse to agree. This disagreement has a name, the Hubble tension. Right now, nobody knows why this is happening. Something might be missing from our understanding of the early universe. Now, just when astronomers thought it couldn't get stranger, the James Webb Space Telescope kicked the door down. It spotted some impossible early galaxies. These galaxies show up just 500 to 800 million years after the Big Bang. According to everything we thought we knew, galaxies at that age should look messy, small, and half-finished. But instead, Webb keeps spotting galaxies that look like they've had billions of years to grow up. They already show organized shapes like disks and bulges, basically the same structures you see in modern galaxies like the Milky Way. Features like that should take several billion years to form, not a few hundred million. It's like meeting a teenager who somehow has the wisdom of an 80-year-old. Now, in some cases, smaller galaxies seem to pack more mass than bigger ones, which also completely flips our expectations. Even cooler, some of those early galaxies contain heavy elements like oxygen and carbon. Stars make those elements, But stars need time to cook them up through nuclear fusion. Seeing heavy elements like that early is like finding baked bread before anyone invented ovens. Either the universe evolved way faster than we thought, or our timeline is missing entire chapters. Another weird headache in cosmology is all about lithium. Yep, the same element in phone batteries. According to the Big Bang idea, the early universe was insanely hot and dense, hot enough to smash particles together and create a tiny amount of lithium. Not much, but enough that we should still see about 5 lithium atoms for every 10 billion hydrogen atoms floating around today. Astronomers can actually check this by looking at stars. They use a trick called spectroscopy, which means splitting starlight into colors to see what elements are inside. Now, to estimate a star's age, they look at iron. Iron only forms in supernova explosions, so stars with very little iron are super old, born when the universe was still young. But here's the problem. Those ancient low-iron stars barely have any lithium. Not just a little less, sometimes less than 1/20th of what the Big Bang predicts. And the older the star, the worse the mismatch gets. Scientists call this mess the lithium problem, and it's been haunting cosmology for decades. Some researchers tried to explain it by saying stars somehow destroy lithium internally. But every version of that idea crashes into other observations. Instead of getting better, the problem keeps getting worse. And when a simple element refuses to behave, it usually means our picture of the early universe still misses something big. Well, dark matter adds another dark spot to the picture. Scientists invented it to explain why galaxies don't fly apart. It acts like invisible glue. Models predict dark matter should pile up densely in galaxy centers and form sharp spikes. But observations keep showing smooth, soft cores instead. It's like expecting a mountain peak and finding a gently rolling hill. That mismatch shows that dark matter isn't behaving the way scientists assumed at all. Some of them even suggest dark matter might feel a fifth force, something beyond gravity, electromagnetism, and other known forces. That idea sounds wild, but it neatly explains why dark matter spreads differently than predicted. If it turns out to be true, it would change how we perceive the way galaxies form, how they evolve, and how the universe structures itself on every scale. And finally, there's dark energy that has confused scientists ever since they stumbled on it about 25 years ago. It makes up most of the universe, and we still don't know what it is. The default idea said dark energy stays constant, like a built-in pressure of empty space itself. Some theories linked it to quantum fluctuations, which are tiny particles popping in and out of existence in empty space. But when scientists calculated how strong that effect should be, they got a value trillions upon trillions of times too big. So clearly, something didn't add up. Now, a massive project shows that dark energy might not be constant after all. Instead, it might have peaked about 4.5 billion years ago and slowly weakened since then. If that's true, dark energy changes over time. Why does this matter? Because dark energy controls the universe's future. If it stays strong, the universe keeps expanding faster and faster until galaxies drift so far away we can't see them anymore. A scenario called the Big Freeze. If dark energy weakens enough, gravity might slowly fight back, expansion would slow, and galaxies that are currently disappearing could drift back into view. All these problems share something unsettling. They're systematic. They repeat across instruments, methods, and research teams. Random errors don't behave this consistently. The universe keeps giving conflicting answers, no matter how carefully scientists ask the questions. That's why researchers call this a crisis, not because science failed, but because it's working exactly as it should by revealing where our ideas fall short. Attention, attention! Something very exciting is going on Saturn. It's called a spoke season, and no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place, that's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex whirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the Moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that. A recent shocking discovery, shocking I tell you, shows that one galaxy can devour another smaller one, leaving behind just faint remains. Can anything like this happen to our home Milky Way galaxy? And if it does, what will happen to the inhabitants of the planet Earth? You know, us. Well, let's figure it out. This whole discovery is actually a curious story. Even before the Rubin Observatory, an astronomical observatory in Chile, even started its full science work, it accidentally helped astronomers spot something totally unexpected. In June, the team released its very first test images, and one of them showed a deep look at the Virgo cluster. That's a huge group of nearby galaxies scientists have been studying for years. But in the bottom right corner of that image, there was something thin and strange, and it wasn't me. It was a tiny razor-sharp streak of stars stretching away from a well-known galaxy called M61. No one had ever seen it before. Now, M61 looks a lot like our own Milky Way galaxy. It's a barred spiral galaxy with long, sweeping arms. But despite the similar shape, the center of M61 is far more dramatic. While Milky Way's supermassive black hole sits quietly, almost as if it's asleep, M61's black hole is wide awake and hungry. It feeds on surrounding matter and blasts out powerful flows of energy, which creates a kind of galactic storm that spreads through the galaxy. M61 has been studied for decades, but Rubin's camera is built to pick up things that are extremely faint. That's why this new star system suddenly appeared. It was as if someone turned on a flashlight in a dark room. Now, the stream is enormous. It's about 50 kiloparsecs long, which is roughly 163,000 light-years. That's more than the size of the entire Milky Way. Most stellar streams around our own galaxy are only a few tens of thousands of light-years long, so this one is huge by comparison. Scientists think that the long trail is made of a dwarf galaxy that got too close to M61. Once it crossed into the larger galaxy's territory, the dwarf galaxy became trapped in its gravitational grip. Little by little, powerful tidal forces began pulling it apart, stretching it into a long, faint trail of stars. Eventually, it was completely ripped apart by M61's gravity. When that happened, the larger galaxy seemed to have responded with a burst of new star-making about 10 million years ago. It almost felt like the collision kicked it awake. This process, large galaxies tearing smaller ones apart, is thought to be one of the main ways galaxies, like the Milky Way and M61, grow over billions of years. Each smaller galaxy that falls in becomes fuel for the larger one, adding stars and gas, and sometimes this process can even stir up activity around the central black hole. Will our Milky Way become that smaller galaxy one day? Well, we do have a much bigger neighbor, the Andromeda Galaxy. But at the moment, we can't predict whether it'll get hungry enough to attack the Milky Way. Whew, what a relief. Anyway, it might seem weird that the M61 stream had gone unnoticed for so long. It wasn't exactly faint or subtle, glowing with the light of about 100 million suns. Hard to miss. But it managed this trick by staying hidden behind a nearby galaxy. This makes it really difficult to detect even bright stellar streams. To find them, we need extremely sensitive instruments and careful techniques. At least now we know that giant galaxies may grow by eating smaller ones, leaving long trails of stars behind as evidence. The researchers admit that it's surprising that such a huge structure stayed hidden around a famous galaxy for so long. And it seems that the discovery of the M61 stream is just the beginning. The night sky might start filling with new uncovered structures, ghostly trails, forgotten galaxies, and the remains of ancient cosmic encounters. The Rubin Observatory is a brand new astronomy center built on a mountain in Chile. Its full name is the Vera C. Rubin Observatory. It was named after the astronomer who first found strong evidence that dark matter is real. Now, what makes Rubin special is that it's the first telescope of its kind. Its giant mirrors, super-sensitive camera, fast movement, and powerful computers all use cutting-edge technology. The main telescope, called the Simony Survey Telescope, has a 27-foot mirror, and it uses the LSST camera, which is the biggest digital camera ever made. But we'll talk about it a bit later. For 10 years, this telescope will take extremely detailed pictures of the southern sky. It will scan the entire sky every few nights, creating a huge, high-quality time-lapse video, the largest movie of the universe ever recorded. This movie will help scientists spot things that change over time, like asteroids, comets, stars that get brighter or dimmer, and exploding stars called supernovae. To create this giant time-lapse, the Rubin Observatory will have to use a lot of new technology. Some of its parts were invented from scratch, then others were improved versions of older designs. It'll help scientists discover all kinds of things. Many we already expect, and many we can't even imagine yet. Even so, Rubin Observatory was built with 4 main science goals in mind: learning more about dark matter and dark energy, creating a complete list of objects in our solar system, mapping the structure of the Milky Way, and studying objects that move or change brightness over time. Everything about the telescope, its huge size, fast scanning speed, and ultra-sensitive camera, was designed to make discoveries in these 4 areas as complete as possible. Rubin's telescope isn't the first telescope with a mirror about 27 feet wide, but it is the first to combine its primary mirror and tertiary mirror into one single surface. Putting both mirrors together is a special innovation that makes the entire telescope more compact. Because of this, it can move faster and get ready for its next observation much more quickly. The telescope's LSST camera is the biggest digital camera ever created. It's about the size of an SUV and weighs around 6,000 pounds. It holds a giant 3,200 megapixel CCD array. Just one single picture from Rubin is so large that you'd need about 400 Ultra HD TV screens to display it. It's also the fastest-moving large telescope on Earth. Rubin's telescope can swing into a new position in only 5 seconds and immediately start taking its next image. This speed comes from the telescope's compact design, thanks to its 2-in-1 mirror and its powerful drive motors. They can quickly move and stop the 220-ton telescope mount without shaking it. Even small vibrations can ruin an image, so this stability is a huge achievement. By the way, if the telescope were spinning at full speed, you wouldn't be able to outrun it. Also, Rubin Observatory has a rare combination. It can collect a lot of light and capture a very large area of the sky in a single picture. This means it can spot faint objects spread out over a wide region without needing many separate images. When you add the telescope's incredible speed, you get the perfect setup for creating Rubin's ultra-high-definition 10-year time-lapse of the universe. A fun fact, each Rubin image covers about 10 square degrees of sky. That's the same area as 45 full moons, or about the size of a golf ball held at arm's length. Another cool thing is that Rubin data will be immediately available to scientists in the US and Chile, and to members of Rubin's International In-Kind program. They'll be able to access everything through an online portal, which means that no giant downloads are needed. After 2 years, the entire world will be able to view Rubin data. Rubin will also process new images every night in near real time. If something in the sky moves or changes, the system will send out a public alert within 60 seconds. This will allow scientists to respond quickly and point their telescopes at the event. Each night, Rubin Observatory will create 20 terabytes of data and send out up to 10 million alerts about changes in the sky. By the end of the 10-year survey, Rubin will have produced a whopping 60 petabytes of raw images. It'll be the first time so much astronomical information is shared with so many people. Okay, see that tiny dot in the dark sky? Squint. Still nothing? No wonder. Even though it's very close to Earth in cosmic terms, it's still 18 light-years away from us. But one day, this distant world you can't see with the unaided eye might become a new home to us, because it likely has all the right stuff for life. They're calling it GJ251c, and it's a super-Earth. Now, a quick side note. Super-Earth sounds epic, but it doesn't mean it's some fancy version of Earth with superpowers. It just means it's bigger, somewhere between Earth and the gas giants like Neptune. These planets can be rocky, gassy, like me, or a mix of both. The super only refers to size, not whether you could actually spend your vacay there. Now, this planet sits perfectly in what scientists call the Goldilocks zone. It's not too hot, not too cold, just right for liquid water to hang around. And where there's water, there could be life. We're talking about at least some weird bacteria with serious survival skills. Of course, scientists are still trying to crack the code of what actually makes a planet come alive. There's a whole mix of conditions: distance from the star, atmosphere, and temperature, and GJ251c looks like a top contender. The first thing astronomers check when they stumble across a new super-Earth is if it's rocky like Earth or just another ball of gas like Neptune. Because so far, Earth's still the only rocky world we know that actually supports life. And second, could liquid water exist there? Because water is the ultimate life ingredient. Finding a planet that checks both boxes is super rare. Out of the thousands of exoplanets discovered so far, only a tiny handful hit that sweet spot. So when astronomers realized GJ251c might be one of those, and that is just 18 light-years away, well, they got pretty hyped. The planet star GJ251 is a red dwarf, a small, cool star about 1/3 the size of our Sun. Because red dwarfs don't put out as much heat, their Goldilocks zones are close in, which actually makes planets easier to find. They whip around faster, so scientists can pick up their orbital patterns more easily. Scientists have been keeping an eye on this star for a while, having collected over 2 decades of data. They already knew it hosted one planet, GJ251b, another super-Earth that orbits every 14 days. But sadly, it's way too close to the star to be habitable. But then, digging deeper into the data, the team spotted hints of another world. It was GJ251c. This one looked promising. So astronomers started watching how the star itself wobbled slightly. Those tiny shakes happen when planets tug on their stars with gravity. The bigger the planet, the harder it pulls. Unexpectedly, the researchers didn't just see the signal from the known planet, GJ251b, there was another tug. GJ251c circled its star every 53.6 days. Now, the catch is, we still don't know much about this new world. We got its mass, sure, about 3.8 times heavier than Earth, but since it doesn't cross in front of its star, we can't tell how big it is or what it's made of, yet. Basically, we found its gravitational footprint, but not the planet itself. Still, astronomers are excited. The new world is bright, close, and perfectly placed for future missions to actually see it directly. That's like going from hearing a noise in another room to opening the door and seeing what's making it. Now, at the same time, that kind of direct imaging is incredibly hard. Stars are bright, and planets are tiny faint specks right next to them. But the new generation of telescopes, the big ones being built right now, might finally have the tech to pull it off. For now, the team's being cautious. The discovery looks solid, but they want to confirm it with even sharper instruments. The next step might literally be seeing this world with our own eyes, well, through a billion-dollar telescope. But for now, it's a really promising mystery world. It's just a matter of looking closer. But let me tell you another thing, and I bet you didn't expect anything like this. Even if another civilization existed on GJ251c or some super-Earth, they might be totally stuck at home. A new study suggests that for all their fancy tech, they'd have a seriously tough time getting off the ground. And I mean it literally. The problem? Gravity. It's a total spoil sport. The thing is, super-Earths are way bigger and heavier than our planet. As a result, their gravity pulls a lot harder. And when gravity cranks up, so does the fuel bill. It skyrockets, pun intended. Launching a rocket from one of those worlds would take exponentially more fuel than it does here on Earth. On a planet that's about twice Earth's radius, the mass can jump to roughly 10 times that of our home planet. That means gravity could be more than twice as strong as what we feel on Earth. Think weighing 300 pounds instead of 150 just by standing there. Ew. Now, this extra gravity isn't all bad. It helps keep a thicker atmosphere, which means better protection from cosmic rays and radiation. That's great news if you're a microbe trying to evolve without getting zapped every few minutes. The thicker air could also help regulate temperature and even support more complex weather systems. So, for life starting out, that's a big thumbs up. But when it comes to building rockets, it's a total nightmare. That same gravity that holds the atmosphere also chains you down. For example, let's take Kepler-20b, a super-Earth about 1.87 times Earth's radius and 9.7 times its mass. There, a chemical rocket trying to launch just 1 ton, which is about the weight of a small car, would have to be 3 times the size of the Saturn V, and that's the biggest rocket ever built, which carried about 45 tons to the Moon. Even if our hypothetical super-Earth inhabitants were smart enough to dream of space travel, they'd quickly run into a gravity-sized problem. Sure, they might try to build launch pads high up in the mountains to shave off some of the crushing gravity. But on big planets, mountains don't get tall. The immense gravity just squashes them down before they can grow sky-high. Oh, by the way, that's why the tallest peaks in our solar system aren't on the big planets at all. Mars, which is quite a lightweight world, hosts Olympus Mons, a volcano that towers 13.5 miles high. But on a much heavier planet, mountains that tall would collapse under their own bulk before the rocket builders even got halfway up. So, our poor super-Earth engineers would probably need to build massive artificial launch towers just to get closer to thinner air. If they had flight technology, like airplanes or helicopters, they might try flying their rockets up first and then lighting the engines in midair. We're actually inching towards something like that on Earth with air-launched rockets. But what if that planet was a water world, and a lot of super-Earths might be? In that case, their smartest species might not even live on land. They easily could be aquatic geniuses. Picture dolphin-like engineers or squid astronomers, forced to launch rockets from underwater. Kind of ballistic missile submarine-type space launches. But even with all that effort, the physics is still tough. For a super-Earth about 10 times Earth's mass, chemical rockets could technically work, but the cost would be ridiculous. You'd need so much fuel that you'd have to burn through a sizable fraction of the planet just to get one ship into orbit. The only real options for super-Earth civilizations might be nuclear-powered rockets or space elevators made of materials stronger than anything we've discovered. Until then, those creatures might stay stuck on the ground with no satellites, no space stations, and no super-Earth NASA. So, as our telescopes keep spotting new, potentially habitable worlds, we probably shouldn't expect to find any weather satellites circling above them. If there's life out there on the super-Earth, it's likely gazing up at the stars, wishing it could visit them, just like we once did. Now, don't be nervous, but there is a hole in our universe. Is it leaking? It's larger than anything we've seen before. The human mind can't even imagine something this huge. Well, mine sure can't. Is it a growing black hole? Is our solar system going to end up sucked into this giant nothingness? Am I blowing this all out of proportion? Well, let's figure it out. The universe isn't packed evenly with stuff. Huge empty areas, called voids, make up about 80% of it. Our own Milky Way even sits inside of one, known as the local hole. But one void is on a whole different level. It's called the Behoudy's Void, and people often nickname it the Great Nothing. It's a massive, almost empty bubble of space located far away in the Behoudy's constellation. Its sheer size makes this bizarre formation unbelievable. The Behoudy's Void stretches a whopping 330 million light-years across. For comparison, our little solar system has a width a bit more than 3 light-years. Yet the Behoudy's Void contains very few galaxies. Compared to the rest of the universe, it's basically empty. That makes it one of the largest known voids, and one of the biggest empty spaces we've ever found. If our galaxy were inside the Behoudy's Void, we wouldn't have seen any other galaxies for most of history. Until the 1960s, our telescopes just weren't powerful enough. Other galaxies would have been way too far away and too faint to spot. It wasn't until the 1960s, when telescopes got much better, that we could finally see very faint, faraway galaxies. If we had been living inside that void, that's when we would have first realized other galaxies even existed at all. But let's figure out a very important question. How do such giant empty spaces even form? After the Big Bang, all the matter in the universe started spreading out, but it didn't spread out perfectly evenly. Tiny random differences, called quantum fluctuations, meant some areas had a little more matter than others. The denser areas had stronger gravity, so they pulled in even more matter. Over time, this left other regions almost empty. That's how galaxies clumped together, and how huge voids were created in between. So over time, galaxies attracted each other too, linking up into long thread-like structures called filaments. Together, those filaments formed a massive foam-like web across the universe. The galaxies gathered along the threads, while the empty spaces in between became voids, kind of like bubbles in foam. Smaller voids slowly merged into bigger ones, which is how enormous regions like the Behoudy's Void formed. Today, filaments and voids make up the largest structures in the universe. The filaments are hotter and more energetic, while the voids are colder and much emptier. Now, the Bohodi's void is enormous. It makes up about 0.35% of the diameter of the entire observable universe. But inside this massive space, there are only about 60 galaxies, mostly stretched out in a tube-like shape through the center. Normally, a region this size would contain around 2,000 galaxies. The void is also surrounded by massive galaxy clusters, like Ursa Major, Shapley, Hercules, Corona Borealis, and Bohodi's. This makes the emptiness in the middle even more shocking. Now, scientists first noticed those huge empty spaces and big galaxy groups in the 1970s, when new technology finally let them see the universe in 3D. As for the Bohodi's void, it was discovered in 1981 by American astronomer Robert Kirshner from the University of Michigan, which also has a pretty good football team. At the time, he and his team were mapping the universe in 3D by measuring how fast galaxies were moving away from us. This method is called a redshift survey. So while doing this, they noticed something weird, a huge region of space where almost nothing showed up. It was basically a giant blank spot on the map. Scientists ruled out a few dramatic ideas right away. The Bohodi's void isn't a black hole because it does contain a small number of galaxies, just far fewer than expected. It's also not a dark nebula, which is a dense cloud of gas and dust that blocks out light. The Bohodi's void isn't hiding galaxies. There simply aren't that many to begin with. The Bohodi's void helps scientists learn how the universe changes and grows. Because it's so empty, it's a great place to study dark energy. Our universe consists of normal matter, and dark energy. Normal matter is everything you can see with your own eyes or with the help of instruments. It makes up around 5% of the universe. About 27% of the universe is dark matter, and dark energy takes up around 68%. It's a force responsible for the expansion of the universe. We really don't know what dark energy is, so scientists are excited about any chance to study it and learn more about how it works. Voids are also useful for studying neutrinos, tiny particles that can travel throughout space without getting stuck. They're often called ghost particles because they're almost impossible to catch. They fly through space and through us without leaving a mark. Right now, trillions of them are passing through your body and you don't feel a thing. Neutrinos are made in places with lots of energy, like the sun, exploding stars, and nuclear power plants. They are everywhere, second only to light particles in the universe. What makes neutrinos really strange is that they can change as they travel. They come in 3 types, and they can switch between them while moving. Scientists also don't know how much neutrinos weigh, or which type is the heaviest. Learning more about them could help explain how the universe works. Well, anyway, with time, space missions will look closely at these empty regions. By comparing what they see with computer predictions, scientists hope to learn more about neutrinos and better understand how the universe works. One of such space missions is Euclid. Its data will be used to study and analyze the Bohodi's void and other similar cosmic voids. Euclid's job is to study the dark universe. It does this by making a huge 3D map of space, looking at billions of galaxies as far as 10 billion light-years away and covering a big part of the sky. Now, scientists know that dark energy makes the universe expand faster, and dark matter helps galaxies form and stick together. But they still don't know what either of them really is. By watching how the universe has changed over the last 10 billion years, Euclid helps scientists understand how space grew, how galaxies formed, and what dark energy, dark matter, and gravity might actually be like. Euclid is about 15 feet tall and 12 feet wide. It has 2 main parts. One part runs the spacecraft, like power, computers, and steering, and the other holds the telescope and 2 cameras. One takes pictures in visible light, that's what our eyes can see. The other sees in infrared light, which helps scientists spot very distant galaxies. Now, Euclid launched on a SpaceX Falcon 9 rocket from Florida in July 2023 and officially started doing science in February 2024. It now orbits far from Earth, nearly 1 million miles away. It stays in a special spot in space where it moves with Earth around the Sun. This keeps its view stable and makes it easier to study the universe. Euclid is supposed to work for about 6 years, but it might keep going longer if it doesn't run out of fuel. In October 2024, Euclid released the first part of its huge map of the universe. Over time, it'll scan more than 1/3 of the sky outside our Milky Way galaxy, capturing billions of galaxies, some so far away that their light took up to 10 billion years just to reach us. The images taken by the space probe are about 4 times sharper than those taken by telescopes on Earth. Euclid also studies light in detail to learn what galaxies are made of and how they move. It'll do this for hundreds of millions of stars and galaxies. And all of this will create a massive space data library, one of the biggest ever made by a space mission. Oh, by the way, Euclid was named after an ancient Greek mathematician who helped invent geometry, the study of shapes in space. Scientists picked this name because understanding the shape of the universe helps explain how matter and energy are spread through space. So now you know.
Astronomers detected something strange happening in the darkness of space. They picked up a series of bizarre, unexplained signals coming from distant stars in the Ursa Major constellation. And literally no one can explain their origin. Is it some unknown natural phenomenon or something far more mysterious, more artificial? Let's explore this latest space discovery, the science behind these signals from space, and what scientists believe might be sending them. So, scientists picked up 2 identical bursts of energy coming from deep space. They weren't random and they weren't background noise. They seemed to be precise and even kind of purposeful. The signals came from the constellation Ursa Major. It lies about 100 light-years away from our planet. The star emitting those signals is called HD 89389. It's a little bigger and brighter than our Sun, but nothing too unusual. That is, until 2023. That's when NASA scientist Richard Stanton noticed something he'd never seen before. The star suddenly flashed, getting bright, then dim, then bright again, and it happened in just a few seconds. There were 2 identical pulses, exactly 4.4 seconds apart. According to Stanton, the star's behavior was beyond strange. The changes in brightness were far too powerful to be dismissed as random noise or the result of turbulence in Earth's atmosphere. A star over 1 million miles wide doesn't simply fade in and out like that. For a star to just blink out like that in 1/10 of a second is not the kind of thing science can explain easily. But it got even more curious. And the more scientists looked, the stranger it got. Apparently, this wasn't just a flicker, it was deliberate. It looked like something made that light change. But what could it be? It was a truly deep space mystery. So for the next 2 months, Stanton worked a lot. 1,500 hours of total observation time, checking every possible explanation. He compared the data to lightning strikes, airplane reflections, meteors, and even software malfunctions. And every single time, the result was the same. Nothing matched. That's when the research team had to admit what no one expected. Apparently, they couldn't rule out the possibility that those pulses might be artificial. The thing is, after checking every possible explanation, Stanton realized that their space telescope discovery wasn't something anyone had seen before. It couldn't be explained as static, it wasn't lightning, and it definitely wasn't a passenger plane flying by. But it reminded him of something. You see, back in 2019, astronomers detected another strange double pulse. This one was coming from a hot gas giant called Dimidium, about 50 light-years away from Earth. At first, experts laughed it off and blamed it on birds flying through the telescope's field of view. But the new signal didn't seem like one of those simple mix-ups. So, Stanton kept digging. He looked at everything and concluded that a shockwave in Earth's atmosphere could explain the signals, but that idea didn't quite fit. For all 3 pulses to sync up that perfectly, the timing would have had to be almost impossible. The researchers also looked into other possibilities. Maybe the light was bent by some far-off object in our solar system. Maybe a satellite or asteroid partially blocked it. Or maybe it was caused by refraction or even gravitational waves. But none of those theories really made sense either. Some details were clearly missing for astrophysicists to explain how a star could blink that fast and that cleanly. For now, Stanton believes the only way forward is to study all 3 known events more closely and see which explanations still hold up. You're probably asking yourself, how was this astronomy discovery even made? It started more than 60 years ago. That's when scientists officially kicked off the search for life beyond Earth. They called it the Search for Extraterrestrial Intelligence, or SETI. The pioneer of this undertaking was something called Project Ozma. It was led by astronomer Frank Drake, the same guy who came up with the famous Drake equation. This equation is a way for scientists to make an educated guess about how many worlds in our galaxy might have intelligent life that can send out signals we could detect. The idea is simple. You start with how many stars are born in our galaxy. Then you figure out how many of those stars have planets and how many of those planets could support life. Then you gotta figure out how many of those worlds might actually have living things and how many of those might develop intelligent beings. And finally, you try to calculate how many of those might build technology that could let them communicate with other civilizations, like ours. Now, the equation isn't really meant to give a clear number. It's more like a big thought experiment that helps scientists consider all those different pieces needed for life to exist and be noticed in the universe. Anyway, back in 1960, Drake and his team pointed a giant 82-foot radio dish at 2 nearby stars, Epsilon Eridani and Tau Ceti, and listened for anything unusual. Between April and July of that year, the observatory in West Virginia stayed tuned in, waiting for a signal from the stars. Unfortunately, nothing came through. But the project became the starting point of everything that came after. Since then, scientists have carried out dozens of similar searches using all kinds of wavelengths and technologies to find signs of intelligent life. These days, we call them technosignatures. And while no one's found solid proof yet, there have been a few moments where even experts couldn't rule out the possibility that something, or someone, might be out there. That's where Dr. Richard Stanton comes in and makes the shocking space discovery. Stanton is a NASA scientist who worked on some of the most iconic missions like Voyager and Grace. The latter was a project by NASA and the German Space Agency, where 2 satellites flew around Earth together, side by side. By watching how the distance between them changed, scientists could see how Earth's gravity shifted in different places. That helped them learn about things like melting ice, ocean movement, underground water, and even climate change. But after retiring, Stanton took on a personal project, searching for intelligent life from his own Shea Meadow Observatory in Big Bear, California. Using a custom-built telescope and a photometer he designed himself, Stanton spent years scanning more than 1,300 sun-like stars, not for radio signals from space, but for flashes of light. Unlike traditional SETI studies that focus on radio waves, Stanton's approach, called optical SETI, looks for laser-like pulses, sharp, quick bursts of light that could be used for communication across the stars. This idea actually goes back to the early 1960s, when 2 scientists suggested that advanced civilizations might use incredibly powerful nanosecond laser pulses to send visible signals that could outshine their own stars. For this study, Stanton didn't scan huge portions of the sky. Instead, he focused on one star at a time. He was staring at it for an hour straight and recording its light at incredibly tiny intervals, just 100 microseconds apart. That's fast enough to catch flashes less than a blink of an eye. Then he analyzed the data, searching for any strange repeating patterns and unexplained signals. And eventually, his efforts paid off, and he made the very space discovery we talked about. A sun-like star, about 100 light-years away in the constellation Ursa Major, sent two fast, identical pulses of light. So far, these signals remain unexplained. No one knows for sure what caused those perfect twin pulses. We can't even figure out how far away the source really was. Was something passing in front of the star? Or was the light itself being changed by something we don't understand yet? What we do know is that something strange is happening out there in Ursa Major. Maybe it's a new kind of cosmic event. Or maybe it's something else entirely. And one day, we'll crack this deep space mystery. An ultra-powerful explosion happened just outside the Milky Way galaxy, kinda next door in cosmic terms, and it was unlike anything we've witnessed before. The thing kept blasting again and again, shooting out crazy strong bursts of energy called gamma rays. It was almost an entire day of non-stop firing back in July 2025. In gamma ray time, that's basically forever, because normally gamma ray bursts last from a few milliseconds to a few minutes, not hours on end. But the craziest thing is that this phenomenon might be linked to an elusive and mysterious kind of black hole, the existence of which we haven't proven yet. Scientists gave this phenomenon a complex sciencey name. Usually, these gamma ray bursts happen when a giant star goes off. One big dramatic exit, and that's it. But this space diva didn't get the memo and kept coming back for encores. NASA's Fermi telescope first spotted this bizarre space performance on July 2nd. But then some other space gear, the Einstein probe, realized it had already been blasting the day before. Scientists tossed around a few guesses. It could have been a massive star, like 40 times the size of our sun, that went out in a special kind of way. Not your average star demise, but one that somehow kept its cosmic engine running, like a car that won't stop even after the gas runs out. Another theory is even wilder. Some scientists think those space fireworks might have gone off when a star, likely a tiny one called a white dwarf, got shredded by a black hole. It's like a cosmic blender moment. They call it a tidal disruption event, or TDE. You see, not every star goes out with a giant boom like in the movies. Most just get old, puff up, and slowly fade away, leaving behind their tired little cores. Those leftovers are called white dwarfs, star corpses made of super weird squished up gas. You see, what happens to a star when it goes off depends on how big it was when it was born. Stars that start out kind of small, about the same size as the sun or up to 10 times bigger, usually end up as white dwarfs. Most of the time, these stars run out of fuel and blow off their outer layers, creating a glowing cloud called a planetary nebula. What's left behind is the super hot dense core, about the size of Earth. That's the white dwarf. They're still really hot when they form and slowly cool down over time. After billions of years, they might turn into cold, dark, black dwarfs. But the universe isn't old enough for any of those to exist yet. Anyway, let's get back to our investigation. If this second theory is right, the black hole responsible for this cosmic show wasn't a regular one. To pull off something like this, it would need to be a super rare kind of black hole. One of those mysterious intermediate mass black holes scientists have been trying to find forever. Before we move further, let's take a look at the black hole lineup. Small ones are called stellar mass black holes. They're formed when massive stars weighing somewhere between 20 to 100 suns collapse. Supermassive black holes are real space behemoths. They're millions and even billions of times heavier than the sun. They chill at the centers of galaxies. Even our home Milky Way galaxy has one called Sagittarius A star. This black hole is mostly dormant. It absorbs gas or dust only occasionally, but its estimated mass is millions of times that of our Sun. There might be one more type of black hole: primordial black holes. Scientists think they might have formed in the very first moments after the birth of the universe. That's when pockets of hot material could be dense enough to form black holes. Their masses might have ranged from 100,000 times less than a paperclip to 100,000 times more than that of the Sun. After that, the universe expanded and cooled very fast, and the conditions for forming black holes this way came to an end. These days, 13.8 billion years later, astronomers still haven't found definitive proof that those primordial black holes even existed. On the other hand, it's possible that they could have evaporated as space became older, due to certain processes happening at the edges of their event horizons, aka the points of no return. According to theoretical predictions, lower mass black holes with less mass than a mountain could evaporate more quickly than larger ones. If this idea is correct, then many of those early black holes have already completely dissipated. But more massive primordial black holes could still be lingering across the universe. Anyway, if we get back to the already proven kinds of black holes between stellar-sized black holes and supermassive ones, there are elusive intermediate mass black holes. Scientists think they exist, but they're like Bigfoot. Lots of theories, not much proof. Astronomers think that small black holes might crash into each other and merge over time to form those medium ones, but spotting one is almost impossible. They're sneaky and silent. People often tend to mistake them for star graveyards, clusters of smaller black holes just hanging out. Sometimes, intermediate mass black holes even hide behind groups of stars that orbit them real close. The best way to catch such a black hole is to look for clues. Scientists measure the mass of black holes when they crash into each other, or spot them mid-meal when they're munching on a nearby star. So far, around 300 possible intermediate mass black holes have been found, but no one is totally sure which ones are the real deal. And now, astronomers think they've finally caught this super rare missing link black hole. Right now, it might be snacking on a poor star way out at the edge of some distant galaxy. In a study published on April 11, 2025, scientists talk about a black hole called HLX-1. It's hanging out about 40,000 light-years from the center of its galaxy and roughly 450 million light-years away from us. Using data from NASA's Hubble Space Telescope and the Chandra X-ray Observatory, the team spotted a bright flash, that very tidal disruption event that occurs when a black hole tears a nearby star to pieces. Then they ran computer simulations to recreate the whole thing, and it showed HLX-1 stretching the poor star like space spaghetti. By the way, this process is indeed called spaghettification. Astronomers have their own cosmic jokes, you know? Anyway, scientists first spotted something weird going on with HLX-1 back in 2009. NASA's Chandra X-ray Observatory caught a super bright glow coming from deep space. Turns out, it could have been another tidal disruption event. The glow from HLX-1 hits its peak around 2012, and it's been fading ever since. But of course, there's a catch. Nobody's totally sure it's a real intermediate mass black hole. You see, that light might not be from a shredded star at all. It could be from an accretion disk, a giant, super hot ring of gas and dust swirling around the black hole's edges. And the only way to figure out what's really going on is to keep watching. If the light keeps fading and doesn't flare back up, then yeah, that poor star probably got eaten. Intermediate mass black holes are a big deal because they're the missing link in the black hole family tree. The connect the dots piece in understanding how black holes grow up. There's also an idea that intermediate mass black holes might start out as big stellar mass black holes and just keep bulking up over billions of years until they become those massive, city-sized monsters at galaxy centers. That means most of their lives they're probably lurking way out on the galaxy's edge. Like HLX-1, before they get launched into deep space. And now, some scientists think there could be a sneaky intermediate mass black hole hanging out on the outskirts of our Milky Way right at this moment. Even if there isn't, the research team is still keeping an eye on what's happening after that blast and trying to piece together what in the universe actually caused it. Next up on their to-do list is figuring out exactly where it happened. Once they pin down the location, they'll be able to measure just how much cosmic energy this thing pumped out and how big the explosion really was.